Okay, we have here today another integral. This one's from Caltech Math Meet 2025, number 2. We have the integral from 0 to pi, sine to the 5th x dx. And I think you can see what method I want to try. There is multiple ways, of course, just because, for one thing, the power here isn't that large. So you could just do like trig on this, do kind of like normal methods, creating a u substitution. It's not too bad here, but if the power was larger, I think it's a problem. And then also you could do the Wallace integral on it, but really this is the same thing, but that would work too as long as you did something to change the upper bound. So what we have for our integral is in exactly this form here. We can put a little label on this and we can call this I sub 5 just because of our exponent being 5. This formula actually works the exact same way for cosine as sine. And there's one condition though, we want n to be odd. If n was even, then this right here would just be I sub 0. So it's really similar. I know we've done a lot of these problems where the exponent was like 20, 25 or 100. So this works well for large exponents. So for I sub 5, we can just plug into this and we can get 5 minus 1 or 4 double factorial over 5 double factorial times I sub 1. But now for I sub 1, that's just going to be this same integral when the exponent is 1, which is just sine of x. So that one, you can just kind of really quickly do that one in your head. But doing it out, what you get is minus cosine x from 0 to pi. So then just evaluating this, at pi it's minus 1, so we get 1 minus 1 equals 2. So that's going to be our I1 value. So we just need to expand this out and finish it. 4 double factorial, it's just like the factorial skipping one number. So we skip the 3, it's going to be all even terms. So it'd be like 4 times 2. This one, we can write it as 5 times 3 times 1, and we have this 2 out here. Multiplying it out, 4 times 2 is 8 times 2 is 16 over 15, and that's it. One thing I should mention before finishing up on this formula here, this does have to be something nice. You couldn't have that be like pi over 3. This needs to be a multiple of pi over 4. No, multiple of pi over 2. Sorry, this needs to be some integer multiple of pi over 2. And then when you don't have that condition here, you'd have to use something else. In this case, it wouldn't be bad, right? Because we could just do it out. If it was pi over 3, we would just do normal methods, trig, and do a u substitution or something. Okay, there you go. That's it for today. Thanks so much for watching. Have a good day.